Hello everybody, I'm Dan. Welcome to my Java tutorial series. All the source code for each video tutorial is located on my website at javacjava.com. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. This tutorial is on Octal Literals. I'm going to go ahead and open up my website, javacjava.com. I'm going to hit begin. I'm going to scroll down here to the Octal Literals tutorial. Octal literals are whole numbers of the base 8 numbering system. They are a subgrouping of the general category of integer literals. Octal literals are whole numbers that can be assigned to variables of the following data types: byte, char, short, int, and long. Octal literals begin with a 0 prefix. The octal numbering system uses the numbers 0 through 7, 0, 1, 2, 3, 4, 5, 6, and 7. Here's an example of an octal literal. Octal literal 03 is the same as decimal 3. Octal literal 011 is actually the equivalent of decimal 9. This tutorial will teach you how the octal numbering system works and how to assign octal literals to variables. Let's talk about the caret symbol and exponents. Exponents are shorthand for multiplication of the same number over and over and over again. The number of times a number is multiplied by itself is represented following the caret symbol. Here's how it works. You've got your number, and then you've got your caret symbol, also stated as to the power of, and then the number of times to repeat the multiplication. So, 3 to the power of 3 equals 3 times 3 times 3, which equals 27. 4 to the power of 2 equals 4 times 4, which equals 16. 5 to the power of 3 equals 5 times 5 times 5 times 5, which equals 125. 2 to the power of 5 equals 2 times 2 times 2 times 2 times 2, which equals 32. So that's pretty basic. Let's go over a quick review of the decimal system. Everybody knows the decimal system. You can count from 1 to 100 and keep going on forever if you wanted to. Try to remember way back to elementary school math, we learned numbers in the decimal system are organized into columns. Because you have been using the decimal system so long, you might not even realize the columns are actually read from right to left. The rightmost column is the ones, next is the tens, next is the hundreds, next is the thousands, and so on and so forth. The decimal system is in fact a base 10 numbering system. And the way it works is you take the value that's in this column and you multiply it by 10 to the power of 0. Any number raised to the power of 0 equals 1. And you'll just have to take my word for it. You can Google it if you want to see the proof of concept out there. But yeah, any number raised to the power of 0 equals 1. Any number raised to the power of 1 equals the same number itself, right? So 10 to the power of 1 equals 10. So you take the number that's in this column and you multiply it by 10. So over here in this number we have 1 times 1. So we keep 1 off to the side here. 9 times 10 is 90. We'll keep 90 off to the side here. 10 raised to the power of 2 is 10 times 10, which is 100. So 4 times 10 to the power of 2. So this is 400 over here. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. 7 times 10 to the power of 3 is 7,000. Then you add all the results together. 7,000 plus 400 plus 90 plus 1 equals 7,491. Okay, pretty quick detailed review on the decimal system here. Now let's talk about the octal numbering system. Just like the decimal system, the octal system is read from right to left. The rightmost column is 8 raised to the power of 0, next is 8 raised to the power of 1, next is 8 raised to the power of 2, next is 8 raised to the power of 3, and so on and so forth. You may recall that any number raised to the power of 0 is 1, and I just discussed that briefly there. And now the way the octal system works is you take your number in the rightmost column, multiply that number by 8 to the power of 0. 8 to the power of 0 is always 1. And you remember that number. Then you work your way to the left, multiplying whatever number is in each column by an ever-increasing power of 8. You add up all the results and you will have your decimal conversion. Here are the decimal numbers 0 to 25 in an octal chart. Okay, so this column is 8 to the power of 0. 8 to the power of 0 is 1. 8 raised to the power of 1 is 8. 8 raised to the power of 2, which is 8 times 8, is 64. 8 raised to the power of 3, which is 8 times 8 times 8, is 514. Okay, so now we know our column values here. So this is pretty easy. 0 times 1 is 0, 1 times 1 is 1, 2 times 1 is 1. All the numbers, all the octal numbers 0 through 7 are the same as the decimal representation. Once we get to 8, we move over and because you cannot use any numbers larger. Your number range in the octal system, if you recall, is 0 through 7. There is no 8 in the octal system. You can never have an 8 in any of these numbers down here. So to represent 8 as the decimal 8, or convert it, you put a 1 over in this column. So you have 0 times 1 is 0, plus 1 times 8 is 8. To represent the number 9, you have 1 times 1, which is 1, plus 1 times 8, which equals 9. Right? You can see this pattern going throughout here all the way down till we hit 16, and then basically 0 times 1, 0, 2 times 8, 16, right? This is fairly simple there. All the way down here till we hit 24, 0 plus 3 times 8 equals 24, okay? And 1 times 1 is 1, plus 3 times 8 is 25. Then down here, I put in the number 146, which is octal 222. So 2 times 1 is always 2. 2 times 8 plus 2 times 8 plus 2 times 64. So 2 plus 16 plus 128 equals 146. And then I did, what would the octal number 1234 look like? That would be, translate into in the decimal system. So 4 plus 3 times 8 plus 2 times 64 plus 1 times 512 equals 668. You can also convert really easily using Windows Calculator here. If you go to View and select Programmer here, you can type in octal 1234 and then simply press the decimal here and it'll translate between it 668. Same thing if we want a decimal 146 and we hit octal, right, it would show you 222. Okay, that's a neat little way to convert between the systems. You can also convert between the the hexadecimal and the binary systems too as well. Okay, let's go ahead and scroll down here. Let's hold down our left mouse button while we press the down arrow on the keyboard. Hit Control C or right click and copy. Let's go ahead and get our browser off the window here and go back to Start. Search, type in CMD to open up our command prompt. If you're running Windows 7 or earlier, you can go to Start Run, type in CMD. First thing you're going to want to do is type in Java C and press Enter. You should see a whole bunch of stuff scroll through. If you don't, if you see an error message, go back to my tutorial on installing the Java Development Kit. You'll need to have that working properly. Okay, let's go and type in CLS. CD space / CD is short for change directory. / indicates the root. We'll do MD, which is short for make directory. And Java, I already have that folder, but if you don't, it'll go ahead and create it. We're going to change directories to the Java folder. We'll make another directory called Octal Literals. We'll change directory to Octal Literals. We'll do Notepad, Octal Literals.java, and that'll be our source code file name here. Always has to end in the .java extension. Create that, hit Control V to paste all this in, or right click and select paste. So we got our Octal Literals class definition, we got our main method entry point here, and we've got a bunch of various different variables being declared and assigned here. So and I also did the 5 data types: byte, short, int, char, and long, that Octal Literals can be assigned to. And then we've got just a whole bunch of Octal Literals here. So 0107 short, basically, over here you can see there's nothing in the ones column. We got a 1 in the 8, right? That represents 8 and 16, and you can see I've just gone through and done this all the way up to 7, right? Octal 30 is 3 times 8, 24, 4 times 8, 32. I just threw 41 in here for grins and giggles. So 4 times 8 is 32, plus 1 times 8 is 33. And then over here we've got a 1, and that's in the third column, which is in the 8 to the power of 2, which is 1 times 8 to the power of 2, which is 8 times 8, 64. Okay, then I represented some char characters, my favorite uppercase A and B, which by now, if you've been watching my tutorials, you know decimal 65 is the ASCII equivalent of the uppercase A, and 66 is the ASCII equivalent of the uppercase B. So we got 1 in the 8ths column, sorry, 1 in the 1s column right here, and 1 in the 64 column right here. 64 plus 1 is 65, and then octal 102 is decimal 66. And then I just threw in a big old octal, which is the number 5 20 times here. And then you do have to include the L on there, because that's going to be that's going to be larger than a 32-bit integer. That's going to represent this decimal number right here. And then we just go ahead and display all this to the console. So let's go ahead and save this and run it. Oh. Let's clear our screen. Java C. We pass it the source code file we want to compile, also known as the compilation unit. Java Octal Literals, and that's the name of the class that we want to invoke. And we get basically the results we were expecting here from the comments there. 1, 7, 8, 16, all the way up here. We got our uppercase A or uppercase B, and we get this big old large number here. Okay, let's go ahead and close out of that. Leave you with some final thoughts here. Octal literals are rarely used in Java, but understanding them will help you understand other more commonly used numbering systems such as hexadecimal. That concludes this tutorial. Thanks for watching.